Hi, welcome to this quick start tutorial for the HAL Robotics Framework. Once you've been through the installation procedure, you should find this HAL Robotics tab up here in Grasper. There are plenty of components here for you to play with, but in this tutorial we're going to stick to the basics. The aim is to get a robot with a tool to follow this curve, simulate it, and export robot code so that we can actually run it on a real machine. We're going to start up here in the Cell menu and select a robot. As you can see, not much has happened by placing that component on the canvas. These two interlocking squares indicate that the component can be double-clicked on to open up a pop-up window. It's one of three new dynamics that exist in components with the HAL Robotics Framework, and I'll get to each one as we come across them. So when I double-click, this window that has a whole load of robots listed in it pops up. I'm going to select the ABB IRB 1200-70 because that's what I have next to me here at the office. And once I've selected that, it'll pop into my scene. Again, under the Cell menu, I can select a tool. We imagine that most of you are going to want to create your own tools so that they align with the ones that you actually have at your disposal. But again, if we double click on this tool component, we'll find a couple that are there just to get you started. I've selected an extruder. Once we have a robot and a tool, we need to combine the two together. One more time under the Cell menu, I'm going to select Attach. The Attach component wants a parent and child. In this case, the parent is the robot and the child is the tool. We can see that once we've connected the two to the Attach component, the extruder is attached to the end of the robot arm. And that's all there is to creating a very simple cell. Once we have the cell, we need to instruct the robot to actually do something. What we want it to do is to move around this curve. So I'm going to bring that curve in from Rhino by coming to the Params tab, Curve, and referencing it in. Now unfortunately robots don't understand curves, so we need to convert this curve into a series of targets. Under the HAL Robotics tab, under Motion, we'll find the Target component. This is where the second new dynamic comes in. Any component marked with Template, in this case Template 1 out of 3, means that we can right-click on the black band down the middle and change the shape of the component. So here, this is a motion from frames. What we'd actually like to do is create targets from a curve. You can see the shape of the component changes completely, and it now asks, instead of frames, for a curve. There are plenty of parameters here for us to play with, but we'll stick to the basics and the defaults for the time being. Once we have our targets, we need to get the robot to actually follow them. So to do that, we're going to come into Procedure and select Move. Move asks us for targets. Anything with an arrow means that it's obligatory. And also gives us the option of putting in a whole load of other settings. Once again, we'll leave the defaults for now, but further tutorials will come onto all of those. Once I've set the target in the Move component, we'll see that we have an action in the output. I need to assign those actions to the robot, and I use a controller to do that. See, the controller here has the two interlocking squares. So I'm going to double click and I'm going to pick the appropriate controller. Make sure that the extension for the relevant brand of robot is installed before selecting the controller, or it may not work properly. We can see that the controller has popped into my scene, and it's asking for a robot and a procedure as input. The robot is going to be the combination of the robot and tool that we created earlier, and the procedure is the general term for the robot program, which in this case is simply a series of moves. Now we can see that the scene's already starting to get a little bit cluttered, so it's always good practice to hide anything that we're not using. Once we have our controller in place, we need to solve the trajectory. And solving is simply the process of ensuring that the trajectory is feasible. Calculating the speeds, calculating any singularities, any out of reach issues, and we find solve under simulation and procedure solver. It asks for a controller, and solve here is a boolean whether we should turn the solver on and off. When you're changing your trajectory greatly, it's always a good idea to turn the solver off. If you're making small modifications, then you might want to keep it on to make sure that everything is working as expected. So solve here, I'm going to attach a toggle, and I'm going to toggle it on. You'll see a couple of things have changed in my scene here. The first is this extra line that suddenly appeared, which is actually the robot's current starting position to the first target we've given it. We've also got a couple of arrows that are floating around that are going to tell us the direction of motion of the robot throughout this trajectory. Once we've solved, we can simulate. So again, on the Simulation tab, Execute will place in an execution component and this execution bar. If I plug solution in here, we can see our robot comes up again, and if I hit play, then the robot is going to follow that trajectory. By default, it'll stop at the end. We can reset, hit play again, and ask it to loop. I'm going to stop that there and get on to the final part of this tutorial, which is going to be exporting that procedure, which we now know works, to a real robot. So if we come up to the Control menu, we'll find Export Procedure. It asks us for a controller, which is the controller that currently has the program and the robot connected. Also asks us for a destination. I'm going just to put in a quick location on my C drive. And it also asks us, once again, for a boolean whether it should export or not. So I'm going to create another toggle, and I'm going to export. The first time you export, it'll take a little longer than each subsequent time. Now that I've exported, I can open up that file and we'll see that I have here the appropriate code for the controller that I selected. In this case, it's ABB Rapid code. If we don't like the format of the code, that was in inline declaration, then we can come to the third component dynamic that I mentioned earlier, which is this shift plus up or down arrow that you'll see here. So if I press shift and up, you'll see that the component itself changes shape slightly, but its process is essentially the same. We've just got a few extra inputs. And in this case, the one that's of interest to me is mode, where I can change from inline to pre-declaration mode. And now, when I toggle it on again to export, we can see that my code has changed shape and is now all pre-declared. That's it for this first tutorial. Hopefully it's enough to get you started, and we'll get on to some of the more advanced features in later tutorials.